Hello guys, I am Nitish Raj and today we are going to study one of the dynamic problem that is minimum edit distance. So what is this problem? We have given two strings S1 and S2. We need to find the minimum number of operations, that is minimum number of edit required to transform from one string to other. So we need to transform S1 to S2. Operations shall be carried out on S1 only. Right. Operation here we are calling it as edit. So basically minimum number of operation required to transform one string to another. So what are the operations permissible? Permissible operations are insertion into the first string only, deletion from the first string only, substitution from second to first. Now let us understand with the help of one example. Let us suppose we have S1 string, that is VUOY, and another is boy. Now how do we transform this S1 into S2? We can simply insert S1, insert U in S1 after B. So that is insertion is taken place. So the total cost, the total number of edit is 1, since we perform only one operation. Right. Let us take another example. We have gun and guy. So one can perform deletion of N first and then insert Y. So total number of edit will be 2. Another way is to just substitute. I told you there are three permissible operations: insertion, deletion or substitution. That is replacement. So directly we can replace. So here it is edit, that is number of edit is 1. So this is the minimum. We will pick up this one. Now how do we make a recurrence relation for this? How we proceed? So let us start. Suppose we have a string, first string we are denoting by A. It is from A1 till AM. These are the characters of strings from A1 till AM. So length of this string is M, and another string B is B1 till Bn, that is length is N. Let us denote this D subscript Mn be the minimum number of edit to transform from A to B. Right. So now what is this D0J? D0J means we don't have any first string and we have only second string. Now we want to form a second string from a string where we have null characters. We don't have any characters. Right. For example, S1 is null. We don't have any string, but S2 is egg. And we are only allowed to do operation on S1. And we need to make transform from S1 to S2. So what we will do, if there is no characters, there is empty string in the S1, we will insert in S1. So total number of edit, total number of operation is 1 insert, second insert, third insert. So how many insert took place? Total number of S2, that is second string length insertion. So if we have no string, that is no characters in first string, so what is the total cost will be? Total number of insertion take place from BK string, that is the second string. Right. And K varies from 1 till J. Each of this 1 till N, each of this characters we are accessing from 1 till N. Right. Similarly, we don't have any second string, but we have the first string, and we need to transform the first string to second string. So we need to basically delete everything from first string. So let us suppose this is null and this is a string. We need to transform this into null. What we will do? We will start deleting from here. One can say we will insert here, but as I told you, we are only allowed to perform operation on S1. So we will only perform operation here. So we will delete instead of inserting here, right, which is our constraint. We can't insert or delete or substitute in second. So for that, the value will be total number of deletion take place in first string, that is AK, right? And this I varies from K is 1 till I. So I varies from 1 till M. What is the second this thing? Dij. That is, we don't know about whether this is empty or not. So what is the next step? So this is, if we have the matching character at the end, we will take just simply the number of edits from the previous. This is very interesting. See, we have egg and we have EGY, right? Since these two match, there is no operations. These two match, no operations. These two are not match. So if you see, if these two are match, this is cost null, 0. If these two are match, this is cost 0. That's why. So whatever the cost we are going to calculate in this iteration, if these two are matching, we will just take the cost from the previous one, the previous number of edit, right? Now what is this case? This is if we are going to delete from first string, and whatever the previous value, the minimum of 3, that is, I'll explain you. Basically we are here, we need to compute this, right? So we will check if this U and this A, if these two are not matching. We are already encountered with CU and here CA, right? If this U and A is not matching, we will take the minimum of these two. So minimum is 0, and then the minimum will, so this is the minimum of these all. So what is the minimum? Minimum of 0, and since this is cost 1, this is also cost 1, this is also cost 1, because deletion is one operation on one element, insertion is 1, substitution is also 1. So basically this is minimum of this plus 1, so this will become 1 if these two are not matching. I'll give the detailed explanation of this. So we will only follow this recurrence if AI is not equal to BJ, right? Now we will understand this entire recurrence relation in tabulated format, that is bottom up approach. We'll go through this entire table, how we can form this table, and this will be the final answer, right? So we have drawn this table. This row is denoted by I, which is for first string, and first string is denoted by A here. Second string is this J column, and this is B. So this is A, this is B. We have taken one example. First character is put as null, here it is also null, CUSM, the second string, and the first string is CATMM. Okay, So first we will go by logic for the first row and the first column, and we will also verify through our recurrence relation. Let us suppose we have null string for first and second string is also null. What is the total number of edit, total number of operation to transform from first to second? Of course 0, there will be no operation, right? Now we don't have any first string, right? And we encountered with second string with only letter C. We don't have any first string, we encountered with second string, that is C. So what we have to do, we have to add this C in the first string in order to have transformation. So we need to add, so we are going to insert in first string, that is one operation. So this will be one operation, right? For this, first string is null and the second string is, till so far we have encountered C also and U also, right? So for C, insertion took place cost 1. For U, insertion took place cost 1. So 1 plus 1 is 2. Now if we go by our recurrence relation, if we don't have any first string, what is the insertion cost in the second step? In the second step, if k is equals to 2, sorry, if j is equals to 2, here j is equals to 2, if j is equals to 2, k is equals to 1 till k is equals to 2. So B1 and B2, two insertion from B1 and B2. So that is k is equals to 1, that is B1, k is equals to 2, that is B2. Two insertion, B1 and B2. So two operation, that is 2. So this will be 2. Similarly, this is empty string, we need to transform, that is CUS to be add here. 4 operation, this is 4, right? Now what if we don't have a second string and we have C only in first string? So definitely we need to delete this to make it as a null. So one operation took place. We have CA, we need to make it as an empty string. So definitely we need to delete this. So deletion will cost deletion this also, because till so far we have CA as a string for first string, and here it is null. So two operations, similarly 3, 4 and 5. So if we don't have any second string and we have only first string, we need to perform deletion on first string from k is equals to 1 till I. If we are at fourth character of first string, then from k is equals to 1 to 4, that is 4 operation, A1, A2, A3, A4, all will be delete, right? So this was the easiest part. Now come to second part. Second part says, if these two characters, we have to find this cell value, right? So we need to check first this two, C and C, that is A is equals to BJ. Yes, these two are equal. If these two are equal, we don't need to perform any operation, we will just pick up the diagonal value, right? If these two are equal, not these two, this and this is equal, so we need not to perform any operation, we will just take the diagonal value. So this is coming from diagonal value and this is 0. One can easily understand, if you have a string with only letter C and if you have another string with only letter C, what is the transformation cost? Nothing, it will be 0, right? Now we need to compute this, right? First string is C only, and the second string is till so far is C and U. One way is to quickly think that U is missing here, so we need to add U here. So there will be one operation. Here it will be 1, right? Now let us right. So here it should be 1 because we need to add this U here after C, because C and C is matched. Now let us do with our formula. What formula says? This is diagonal. If ij represents, then I minus 1 and j minus 1 represent the diagonal. J minus 1 represents one column before, that is this direction, and I minus 1 is above, previous row direction. This is previous column direction, this is previous row direction. So in all these 3 directions, the minimum will be checked. So we are here, we need to compute this. We will, if these two are not equal, we will check this 3, right? This, so from here this is I minus 1, j minus 1. From here this is same j but I minus 1. From here this is same I but j minus 1, right? So minimum is here, and we need to take this and add 1, because we are going to perform only one operation. So where we found this minimum? At j minus 1. Now here is a very interesting part. If you see, we went to this j minus 1, and j minus 1 says we are going to insert operations, right? So insert operation, only one insert operation. So if we are inserting one operation, 0 plus 1 is 1, so this will be 1, and we came from this direction, so make this direction, right? Again, for this we have so far encountered C, here we have so far encountered CUS. So this cost will be minimum of these 3 and plus 1, that is 2. Till now we have already included total number of edit till so far for CU is 1. We need to add one more S here, so definitely it is 1 plus 1, that is 2. So for this 3, because C, M and C is not equal, so this will be 3. Now here the similar case, this C and A is not match, minimum of these 3 and plus 1. So minimum of this 3 is 0, plus 1 is 1. We are coming from above, so we'll make this direction, right? Similarly, minimum of these 3, because C and T is not match, 2, 3 and 4. Since M and C is not match, minimum of these 3 plus 4. And we are doing bottom up approach. We first computed for this cell, then we move to next cell. That is the bottom up. So for this, T is not matched with C. So for this calculation, we need to find the minimum, that is 1 plus 1, that is 2, and so on. So for this, U and A is not matched, minimum of this 3, that is this one plus 1. This is this direction, right? T and U is not matched, so minimum of this is 1. Now here U and T is not matched, right? U and T is not matched, so minimum of this is this also, but which one has to pick, right? Which one has to pick? That is the question. Take the any one, but add 1, but we need to see the direction also. So whenever you find this, that this is not matching and the minimum is same here, you just need to delete from above. That is, T is not going to be present for this string. So this will be this. In similar fashion, this will be 3 since u and m is not here. This will be 4 because m and u is not match. For this we till so far CA and we encountered with S, so A and S is not match. Minimum of these 3 is 1, so 1 plus 1 is 2. What we are going to do is to insert this S, so insertion will be this cost. Similarly, this is not match, this will be 3 insertion. This will be S and T is not match. Minimum of this 3, this is 1, this will be 2, taking from here, match 3, this will be 4, minimum of this 3, right? Here it is the minimum of this 3 plus 3. Now here it is interesting, since m and m is match, so if these two are match, we'll just take the diagonal value, that is 2. Here m is match, we'll just take the diagonal value. So this is our answer. Minimum number of edit will be 3, right? One thing is important. If you see, the minimum is here also and minimum is here also, right? So you need to just avoid this diagonal, you just take from above, right? You try to insert, right? So if minimum is in this two also, take this one rather this one, right? So next we will see the entire code in C++ language for this algorithm.
So guys, this is the program in C++ for edit distance dynamic programming problem. So this is minimum method to compute the minimum out of x, y and z. So this is our bottom up edit distance function. This recurrence relation is also known as Vladimir-Levinstein algorithm. Somewhere around 1964 it was first think of this solution. So let's not get into the history. So we have made distance table of dimension m plus 1 and n plus 1. Why? Because the length of the string, first string s1, the length is m and the length of second string s2 is n, and we want to compute for assuming it is a null string for the base case for recursion. So we have taken one extra. This is for first string iteration, this is iteration for the second string. If you remember, we have the base case where if first string is null, there is no string at all for first. So, and we have second string, of course. So what we need to do, we need to insert all characters of second string into the first. As we said earlier, it will be equal to the total number of characters found till so far from the second that will be inserted into the first. So this is j equal to the j d of ij, where I is 0, right? Similarly, if we don't have second string and we have only first string, we need to delete all characters from the first string. In both cases, we are operating on first string only. That is our constraint for the problem. And if the last character are same, if you remember, we need to pick up the, if last character is the same, we need to just pick up the diagonal value, because whatever till last for ith and jth we are already computed, that there will be no cost, like we have CAT and we have CAL. So CA is match. Sorry, we have already encountered with C, and we are going to encounter with A. Since A and A in both CAL and CAT is match, so no need to add since it is matched. So we'll take the diagonal value, that is cost of C and C, which is also 0. Right, so we'll pick up the diagonal value if it is matched. If last character is not matching, we'll try the different possibility. What are the different possibility? Either we are inserting into the first string, as I told you, insertion is j-1. Just rewind this video, you will find why this is j-1, and deleted from first string is I-1 because it is coming from I-1, and substitution, that is the replacement, is from I-1 and j-1, and this 1 denotes that any one of these operation is performed, the edit will be only 1. Here this will be printing, we are printing distance table for the same test case we have seen in our one of the example. So first string is CAT second string CUSM. We are just printing bottom of distance, and we'll also see this distance table, right? Let's see what will be out. The minimum distance, the minimum number of edit is 3, and you can match with our table. This is the exactly same table, right? Now what is the complexity for this program? This program complexity is order of size of first string into size of second string, that is order of m into n, right? So thank you, have a nice day.